Hello everyone, welcome to this video. In this video we shall be solving question 20 from exercise 9.3. So let's have a look at the question. The question here says we need to show that the products of the corresponding terms of these two sequences, the first one in the small letters and second one in the capital letters, we have to show they form a GP and we need to find the common ratio. So remember we have studied about this kind of question where instead of these alphabets A, R, we were given numbers. We need to multiply those numbers and we need to tell what is the common ratio and what is the sum of those numbers in the GP. Here we are given not the numbers but the alphabet. So in terms of alphabets we need to show that the resulting sequence which is obtained by taking the product of this term with this term, this term with this term, this term with this term, and each corresponding term with each corresponding term, that forms a GP. One thing. Another thing, we need to find its common ratio. So let's proceed to solving this question. So for the first GP it is given to us like this. So here you can clearly see A is the first term and R is the common ratio, right? In the second GP you can see that capital A is your first term and capital R is your common ratio. Now what we do, we construct another sequence which is obtained by multiplying the corresponding terms of these two GPs. So multiplying the corresponding terms, multiplying these two together, we would have small a into capital A as the first term. Then multiplying these two together, we would have small a small r multiplied with capital A capital R this term. Then multiplying these two terms together, so it would be AR square into capital A capital R square, and so on. Multiplying the last terms together, we would have this term. Now we need to examine whether the constructed sequence is this a geometric progression or not. So in order to determine that, we should verify that whether the common ratio, the ratio which is obtained by dividing each term by its preceding term, is it the same or not. So let's have a look. So first of all, when you divide the second term with the first term, what do we have? We have small r into capital R, right? Next thing, let's examine when we divide the third term by the second term, what do we have? So when you divide the third term with the second term, you again have small r into capital R. Next, the next term in this sequence would be AR cube into capital A capital R cube, right? So dividing this fourth term with the third term, what do you get? You get again small r into capital R, right? Because you can clearly see the powers, they cancel with each other, one small r and one capital R is left, correct? In a similar manner, all the ratios would be obtained and all the ratios would be equal to small r capital R. We can check for the last term. For the last term, we would divide this last term by the second last term, right? Second last term would be this one. So when you divide both of them, you would have this and this cancelled, this and this has cancelled, this cancelled with all the powers, only one power is left, and this whole cancelled with all the powers, only one capital R is left. So we are again getting the ratio as small r into capital R. So you see, we have the same ratio when you divide the consecutive terms of this sequence, hence this forms a GP, right? Moreover, what is a common ratio? Common ratio is just the number which we obtain each time you divide each successive term. So small r into capital R is the common ratio, correct? So I hope you understood this question well. Well, that is it for this video. Thank you for watching.